Welcome to the last video from this series of using or setting up Butterfly for Dynamo. In this video, I'm going to show you how to set up an indoor analysis in Dynamo using Butterfly. And this is the final result that we're looking for. I assume you have already watched the one that I just recorded. I mean, you don't know I just recorded, but the one that I recorded for the outdoor analysis. So I'll go faster on this one. The main difference here is we will take the geometries from Revit. And for that, I go and open the Revit file that comes with the installation. So I go in Revit, open. This is where the files are. So wherever the package is installed, there is an example file folder, right? And inside that, you will find two rooms RVT. It's a Revit file. The units are in meters. There are two rooms here, and we will be using this room on the south or in the bottom of the page for the modeling. Okay, so the first thing I need to do is actually what's the 3D circuit. So this is the one that we are going to use, the simpler one. You can use this one here too, but then again, like for this example, I'm trying to keep it as simple as possible. So let's go back to ground floor. Let's go ahead and run Dynamo. And this time I go and open indoor study and open in manual execution. So the structure is very similar to the outdoor study. The first part is to create the geometry, get the geometry from Revit this time. That time I generated the box in Dynamo. Here we create butterfly geometry out of Dynamo geometries, which basically means we take this geometry and we add a boundary condition to them. And finally, we use all of them to create a case. In outdoor example, the case was created by just butterfly geometries as like a wind tunnel. But in this case, we are creating a case from the geometries. So it's not a wind tunnel, it's just the geometry itself will be the domain that we want to study. After that, it's like the same as outdoor because it's a block mesh, a snappy hex mesh, and running the analysis, running the solution and visualizing the result. And also in this case, I do visualize the velocity. And here, just the sampling is a little bit different, like the points that I'm sampling is inside that room. Some of you probably, you open this file and you got a question mark here. That's because I'm using this component from this node, as you say in Dynamo, as I should say in Dynamo, this node from Honeybee, which takes a geometry, takes a room and creates, basically gives you the outputs, the geometry of that room. And again, by default, it gives you polyline. I have a Python script here, which gives me the surfaces of the room. If you have a complicated geometry or room, this will fail. And I already know that, and that's why there's a story about that. That's why we opened a Revit IDEA to give us access to Revit windows, the room windows, and they said they're going to do it. It's under review, so we still don't know they're going to do it, but hopefully they will. But if this thing failed for you, it doesn't really matter. Everything that I'm doing up to here is to get the geometry out. So if you want to get the walls, you can do it in your way, select by element, all the other ways that you can do it in Revit. All we need is to get the geometries. That's it. So let's go ahead and make sure this is false. I run this thing for the first time, which basically means only this component, these nodes will run up to here. So this is what I got out of this. Let's again talk about what happened. This node loaded all the rooms and spaces. I have 2 rooms. I picked room number 1, which is the one which is simpler. Then here it created a honeybee zone out of that and gave me the geometries, which I'm not really using polylines. So this component takes honeybee zones and give me all the surfaces. And you can see there is an elements output here that based on that I can understand what is the type of the surfaces here. And I pick the surfaces that I need, so I just separate them here. The inlet is X9, which is the number 9 on the list, which is this surface, this window here. These are the outlets, the other windows, and the rest are walls by definition in a CFD walls. I mean, the boundary condition is set to wall. Again, if you are using another room or another Revit file, then you have to change these values to get the right like the right surfaces for each boundary condition. This Michal is working on a workflow to automate the whole thing. So if you are not a person who like to use Dynamo, you can just use Revit and set up all the inputs on Revit side and then load them to Dynamo. We don't have it yet, but for now you have to do it like this. You have to create all the stuff. Then here for each geometry, I just name them. So wall, floor, roof. I leave the boundary to empty here because the default is wall. For outlet, I set up an outlet boundary for them. For inlet, I'm setting up an inlet boundary. And then I put them all together here to create a case. One thing is, you see, I'm making a poly surface by joint surfaces, and I connect a poly surface here instead of just connecting these surfaces. It should work fine, but I have found cases that it crashes Dynamo. So because of that, I just like always create a poly surface. And again, as I said, this is something that we will probably wrap into the node, so you don't have to do this over and over in the next release. Okay, by that, let's set this to true. Let's go here and turn on this very useful show run preview. So yes, this will be updated. I'll just run this. And let's see. No errors. Everything is fine. Again, if you didn't run the Revit as an admin, this will give you an error here. Let's go to the next step and run the block mesh and the snappy hex mesh. In this example, I'll just run both of them at the same time. But a good practice is always to run block mesh first. Make sure the block mesh makes sense, all the size and everything is good, and then go move to snappy hex mesh. One thing that I use differently in this example is, instead of setting the cell size here, I already set it up here in mesh parameters. And this is important to make sure these values make sense in your units. This file is in millimeters, and then I get 200 millimeters, which is 20 centimeters, which is good enough for what I need here. But you should set it up for your case if you're using another units. With that, we should be good to run this and generate the mesh. So the first window will be block mesh, and then this one is a snappy hex mesh. It should be also pretty fast because everything is simple, and we are not running the snap or the layers. So it's only one round of meshing, one step. The case here is very similar to outdoors, so I'm not going to repeat all the stuff that I said in that video. So you can just, again, let's write it first. Make sure everything goes well. It seems like everything goes well. We have no problem. And then run it. And again, in this case, I set it up to 200. So it just stops after 200 iterations, so we can visualize the results. Again, it's running, and unlike Grasshopper, I cannot interact with the Dynamo interface at the time, so you have to wait. One thing that I have seen people doing is you click here and it stops, and then you stop there forever, and you say, oh, my analysis doesn't run, because this is happening because when you click, it just stops so you can read the stuff. If you want it to continue, just press escape, and it will go back where it should be. So 139, there's a couple of more iterations. Let it go. As you can see, it's far from converging yet. The cases, let's see where we are. Yes, like especially in UZ, it's not there yet at all. So here we go. We have the analysis. It's not converged, I know, like, so you have to run it more if you really want to get the converged result. But again, for here, I want just to show you the workflow. And for that, let's see what are the sampling points that are generated. Here, in this case, we have 2000. You see there's just a horizontal one. You can create a vertical one. You can just put random points wherever you want. Doesn't matter. As far as you have a list of points, it can come here. So it's a flattened list of points here. And let's go ahead and sample the case. Nice. So if it goes well in everything, so now you can see this is the inlet. Those are the outlet. At least right now you get a vortex here, so you don't have that much airflow on the other side. Most of the wind goes out from this window and the other window. You can do a couple of changes in the preview here, because these are the ladybug components. Just we're using, if you don't like the color set, you can change it. If you want to change the domain, you can change all those stuff, or even you can remove the legend parameters. And let me run it again, and then you should get the default color set instead of the one that I just used. Here we go. You see that the colors changed. And I think that's all I have for now. Oh, okay. One last thing to add is how can you visualize these vectors and bring it to Revit? I don't know. I tried and I talked to a couple of people, and Michal actually opened what is that? An issue on Dynamo forum to see if there is a better way to do this. I think like the way, as far as I understand, is to make a family for vectors, but that's not something that I'm the best person probably to do. So if you know a better way to get these values and put it in Revit, let me know. If you do a video on that, let me know so I can share it with other people. And I think we can call this the end of this video. Thanks for watching.